In this video, I will explain how to solve quadratic inequalities. So let's work through a couple examples. Let's say we have x squared plus 2x minus 8 is greater than or equal to 0. So we want to figure out for what values of x make this expression true. So the way that we can do that is we can first factor this left-hand side. So we want to think, what values multiply to negative 8 and add to 2? So that would be a 4 and a negative 2. So we can rewrite this left-hand side as x plus 4 and x minus 2. It's greater than or equal to 0. So now we think, what values of x would make this left-hand side equal to 0? Well, we can see that would be x is negative 4 or x is positive 2. So these are our 2 points of interest. So what we need to do is, let's draw a number line like this. And let's say this side is extending towards infinity, this side is extending towards negative infinity. We want to draw at 2, we have a closed circle, because this expression says that x squared plus 2x minus 8 is greater than or equal to 0. So since we have an equal sign right here, we make a closed circle. And then over here, let's say we have a negative 4 in the number line. We will also make a closed circle, since we have an equal sign in this expression. So the next part that we need to do is we need to look at these 3 regions. So here's the first region, here's the second region, and here's the third region on our number line. And what we need to do is we need to pick a number that lies in each region and plug it in for x and see if this expression is true or not. So for example, let's say this region right here from negative infinity to negative 4. Let's pick a number that's between those two values. So let's say negative 5. And let's plug it in for x and see if it does indeed produce a true expression. So let's say negative 5 plus 4 multiplied by negative 5 minus 2 is greater than or equal to 0. So negative 5 plus 4, that's a negative 1. Negative 5 minus 2, that's a negative 7. It's greater than or equal to 0. So negative 1 times negative 7, that's a positive 7. It's greater than or equal to 0. So let's ask ourselves, is this true? Is 7 actually greater than or equal to 0? Well, yeah, it is. So we would write, let's just write yes right here to indicate that any value between negative infinity and negative 4 is a valid answer for x. All right, now let's check out this next region. We have from negative 4 to 2. So let's pick a number between these two values and plug it in to our equation. So let's choose 0 because that's pretty easy to work with. So we'll say 0 plus 4, 0 minus 2 is greater than or equal to 0. So here we get a positive 4, and here we get a 0 minus 2. That's negative 2. It's greater than or equal to 0. 4 times negative 2, that's negative 8. So let's check, is negative 8 greater than or equal to 0? Well, no, it's not. So we would say that no for this region. Any value that we plug in that is between negative 4 and 2 does not actually produce a number that's greater than or equal to 0. So let's check out our last region between 2 and positive infinity. Let's pick a number in this region and plug it in for x in our original equation. So let's just pick 3. So we'll have 3 plus 4, 3 minus 2 is greater than or equal to 0. So 3 plus 4 is 7. 3 minus 2 is 1. It's greater than or equal to 0. 7 times 1 is 7. So let's check, is 7 greater than or equal to 0? Yeah, it is. So we'll write a yes right here in this region. So what this tells us is x is allowed to be any value between negative infinity and negative 4, or x is allowed to be any value between 2 and positive infinity. So if we want to write that in interval notation, we can write it like this. Valid values of x are negative infinity up to negative 4, and we'll use a bracket since x is allowed to be negative 4. And then we'll union that with bracket 2 comma positive infinity. So these are the values of x that will produce a value greater than or equal to 0 in this original expression. All right, let's check out another example. Let's say we have x squared plus 3x minus 10 is less than 0. So once again, we want to figure out for what values of x make this expression true. So the way that we can do that is we can first start off by factoring this left-hand side. So let's think, what values can multiply to negative 10 but add to positive 3? Well, that would be a 5 and a negative 2. So we can rewrite this as x plus 5 and x minus 2. It's less than or equal to 0. So what values of x would make this equal to 0? Well, we can see that would be a negative 5 or a positive 2. So let's draw our number line once again. And we'll say this is extending towards positive infinity, and this side extends towards negative infinity. And we have, let's see, a negative 5 somewhere over here, and a positive 2 somewhere over here. And now we're going to draw an open circle at negative 5, because we're saying this expression must be less than 0. So there's no equal sign. So at the 2, we'll also draw an open circle, because 2 is not a valid answer. It doesn't produce a value less than 0. So remember, when there's an equal sign, we color in the circles. When there's not an equal sign, we leave the circles open. So once again, we need to check out these 3 regions that we have, and we need to plug in a value from each region into the original expression and see if it's true. So let's start with this first region, negative infinity to negative 5. Let's choose the value negative 6 to plug in to this original polynomial. So let's do that. We'll say negative 6 plus 5 multiplied by negative 6 minus 2 is less than 0. So negative 6 plus 5, that is negative 1, times negative 6 minus 2, that's negative 8. It's less than 0. So a negative 1 times a negative 8, that's a positive 8. It's less than 0. So is this true? Is 8 less than 0? No, it's not. So we will write a no for this region. These are not valid values that we can plug into x to make this expression true. Let's check out the second region. We have negative 5 to positive 2. So we need to pick a number in this region and plug it in to the original polynomial and see if it's true. So let's just choose the value 0 since that's easy to work with. So we'll say 0 plus 5 times 0 minus 2 is less than 0. So 0 plus 5, that's 5. 0 minus 2, that's negative 2. It's less than 0. 5 times negative 2 is negative 10, less than 0. So is this true? Is negative 10 less than 0? Yes, it is. So we'll write a yes for this particular region. Now let's check out our last region. We have 2 to positive infinity. Let's pick a number in this region and plug it into the original expression. So let's pick a 3. So let's say 3 plus 5 times 3 minus 2 is less than 0. 3 plus 5 is 8. 3 minus 1 and minus 2 is 1. So 8 times 1 is 8. 8 less than 0. Is this true? Is 8 less than 0? No, it's not. So we're going to write no. And right here we can write a no. So we can see the only valid values that we're allowed to plug in for x are between negative 5 and 2. So if we wanted to write that in interval notation, we could say from negative 5, remember we use a parentheses, not a bracket, since we're indicating negative 5 is not one of the valid answers, up to positive 2. And we'll write another parentheses instead of a bracket, because remember, a parentheses indicates 2 is not included as one of the valid answers. So we can plug any number between negative 5 and 2 in for x into this original equation to make this left-hand side less than 0. Thanks for watching.